Hello everyone. I've been wasting a lot of time scrolling through endless feed of TikToks, and I decided I will do something productive, which is unraveling the technologies behind uh, the algorithm or the recommendation system. So the first thing I did is I went through the uh, TikTok website and tried to understand how they're using what is the recommendation system that they're using. I didn't find anything useful, so I googled and I found these two papers that were released by ByteDance, which is TikTok's parent company, and I will do my best in this video try to explain what I uh, researched. First, for any recommendation system, you will need to do two things, either collaborative filtering or content-based filtering, and most recommendation system combine both. So for collaborative filtering, you need to understand how are the users similar to each other, and that you can find out using uh, the information which is what language are this user speaks, or what country is he from or she from, what is the time of the day, what is the device type, like whether it's an iOS or Android. This way, you can find the similarity between a user and each other. That's collaborative filtering. For content-based filtering, you need to understand how is the content similar to each other and how is the user interacting with different pieces of videos or content on TikTok. This is done through gathering interactions like likes, comments, shares, views, things like that, and running uh, so running a convolution neural network on a video when a creator uploads the video. This is done so that TikTok understand what this video is about, and uh, rem- removing any inappropriate content that is being uploaded, and other things like the creator adds a caption, sound, hashtag, uh, what is the video popularity currently. These are things that are related to the content. So now we have these things are concatenated together to create an embedding. I will not go through how this embedding is created, but it's usually using an embedding model. So now we have a user mod embedding and a content embedding. One thing that I need to mention that introduced in one of their papers is something called Cuckoo HashMap. It's a funny name, but um, usually people or like large scale organizations store embeddings in embeddings tables using hash tables or hash maps. So to store an embedding in a hash map, you need to run it through a hashing function. But this hashing function has the issue that it might have a collision. And once you have a collision, you will lose the data that was already stored in this bucket. So the innovative solution that they introduced to the Coco hash map is that they created, instead of one hash map, you have two hash maps. And if there a collision happens, you will use another hash function to move the already stored uh, embedding into another embedding, and then you do that iteratively. I don't know till when, but that seems to solve the problem. So now we have our embeddings, user embedding and content embedding. They already stored in the embedding tables. Here comes the architecture, the the architecture behind the recommendation system itself. You have as input the user and content embeddings. This is called a deep FM architecture or deep factorization machine, which combines the strength of deep neural networks that is able to find the complex patterns inside the data. That is the characteristic of neural networks, with a factorization machine which identifies the linear correlations in your embeddings or in your data. So you know now the simple and the complex patterns inside your data. Uh, these combined will help you or or help the system suggest the best recommendation. So TikTok is nothing without its continuous updates and its continuous model updates. So that they have this architecture where the user actions will be logged using Kafka, and the model that is already suggesting content to the user have features. This will be combined using a Flink streaming engine job. Both will be joined, and in the case of online training that we're interested here, the worker will do the training, and the updated gradients or updated parameters will be synchronized with the live model that is being served or generating the recommendations for the user. The good thing that they have here is that they have a unified pipeline between online training and batch training, so that there is no issues or like differences between both that might cause issues in production. Uh, so online training happens with every single point. Batch training, they didn't mention what is the period that they do this batch training, but they have it in handy, and it's using Hadoop distributed file system to store the training examples that is being generated live. One thing is the way that they uh, serve their model is following the TensorFlow architecture, where you have different machines working on the training process. You have workers. These are machines responsible for calculating the gradients and updating the model parameters, while the parameter server is like the state, keeping the state of what is the current status of the model, what is the weights now, what is the biases, so that in case of failure, we have multiple of them so that we are sure or know what is the current model status. So yeah, that was it. I tried my best to understand and use my time better instead of just scrolling, trying to understand the things or like technologies behind the TikTok algorithm. Interested to know your thoughts, and please like add your comments in the discussion, and see you in the next video. Thank you.